In this video, let's go ahead and practice writing some linear equations for some parallel and perpendicular lines together. We're going to be given a linear equation and point, and our job is going to find the equation of two different lines, one that is parallel and one that is perpendicular. While one equation is going to be parallel to the original equation, the other one is going to be perpendicular. However, both equations need to go through that given point. Alright, starting off, let's look at this given equation, and I'm just starting by copying it down. Currently, this equation is written in standard form, so it's a little bit hard to tell what the slope is. Let's go ahead and rearrange it into slope-intercept form, or that y equals mx plus b form, so we can tell what the slope is. If we go ahead and subtract 3x from both sides, we can say that negative 4y is equal to negative 3x plus 6. And then if we divide both sides by negative 4, we can see that we have this equation of y is equal to 3/4 x minus 3 over 2. Now keep in mind that from this, we only really care about the slope being 3 over 4. In order to write the equation of a parallel line to this equation over here, we're going to need to use the fact that the slope of this parallel line is going to also be 3/4. But we also have to make sure that this line goes through this point of negative 3, 1.5. On the other hand, for our perpendicular line, while it also needs to go through this point of negative 3, 1.5, we have to make sure that we don't use the same slope here, rather we use the opposite reciprocal slope. So the reciprocal is going to be 4 over 3, and the opposite is going to make it a negative 4 over 3 for that slope of the perpendicular line. Now that we have all the information we need for the parallel and perpendicular line, let's go ahead and write these equations. Alright, let's start with the parallel line first, which has the same slope. So to write this equation, let's go ahead and use our point slope form, which is this y minus y1 is equal to m times the quantity of x minus x1. Now let's go ahead and substitute in this negative 3 in for x1, 1.5 in for y1, and this positive 3 over 4ths in for the slope. Alright, so this is what the equation is going to look like in point slope form. Let's just go ahead and practice turning this into slope-intercept form, or that y equals mx plus b form, just in case. If we go ahead and distribute this 3/4 and we also turn this 1.5 as a decimal into a fraction of 1.5 or 3 over 2, we're going to get y minus 3 over 2 is equal to 3/4 x. That's going to be 3/4 times x. And then we have this 3/4 times 3, which is going to just equal this 9 over 4. Next, we can go ahead and add 3/2 to both sides. And when we do that, we're going to get this equation right here, which is the equation of a parallel line to the original equation that goes through that point of negative 3, 1.5. Now, as for the perpendicular line, we're going to use point slope form again, where this negative 3 is going to be x1, this 1.5 is going to be y1, and then instead of the slope of being 3/4, we're going to have negative 4 over 3, and that's going to be our m value here. So let's go ahead and substitute those values in. Substituting in, this is the equation we're going to get in point slope form, but just like earlier, let's go ahead and distribute this slope here so we can turn this into slope-intercept form so we can see what that looks like. So if we go ahead and distribute that slope as well as we turn this decimal into a fraction, we're going to get y minus 3/2 is going to be equal to negative 4/3 x. And then we're going to have to subtract here 12 over 3, which is just going to be 4. And finally, if we add 3/2 to both sides of this equation, we're going to get that y is equal to this negative 4/3 x. And if we take this negative 4 and add 3/2 to that, that's negative 4 plus 1.5. That's going to be negative 5 over 2, or negative 2.5. I'm just going to keep it as an improper fraction though. So this equation right here would be the equation of the perpendicular line to the original equation that goes through that same point of negative 3, 1.5. Now, in case you wanted to see all this on a graph, just so you can visualize what's going on, this equation right here is the original line that we were given in the problem. It has that slope of positive 3 over 4. This line over here is that parallel line, and this one is the perpendicular line. Now, not only are these lines parallel and perpendicular to that original equation, but they also both go through this point of negative 3, 1.5. Alright, so that wraps up this video where we were given an equation as well as a specific point, and we came up with another equation that was parallel to it going through that point, and an equation that was perpendicular that also went through that same point. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.